There we go. Oh, well, I was enjoying the presentation. How'd you all like it? Okay,
It was
back.
restful.
Okay, back
We
up.
can hear you now, though.
I know we're in good shape. Thank you for the reminder. You could see my lips move, but no wisdom was coming out. Anyway, Bill Ragsdale, the founding president of the Fourth Interest Group, guided it for a couple of years along the way. Uh, in the 80s or 90s, whatever, I did a fade because I had a family and a life. And now the family and the life have gone away, and I'm back to Fourth. So, and enjoying it immensely. Presentation today is actually the completion from last month. Last month, I kind of outlined this project and presented pseudocode, and now I have fleshed it out and actually done the application, at least phase 2 of the application. And so the project is being able to translate CSV files into a database, particularly using Forth. I assume we're all familiar with the CSV files, comma, separated values, very common for transfer between databases and spreadsheets and so on. So the goal here is to parse out the actual elements. We'll see what their structure is like. We have to adjust for some reserved characters, which are comma, double quote, and return and line feed. And most CSV translators allow you to pick what the reserved characters are. And then the third phase is to assign data formats to the elements. Basically, what I'm doing is taking a spreadsheet and reconstructing it via CRLF files into a Forth database. So let's talk about the reserved characters. First, the comma separates each data element. And if you place text between double quotes, it will be transferred exactly as is. It may contain reserved characters also, and they're allowed for. Double quote within a literal string, that is, if you have a literal string going and then there's a double quote within it, that is a 2-element symbol, which will be represented by the double quote. And finally, the end of each line is demarked by the ASCII return and line feed. And at the end of the file, the sequence just ends with a CRLF. So it's up to you to figure out the end of the file. Here's a couple of the cases. There's 3 of interest. The first one I'm calling literal case 1 is simply if you have a text string delimited by double quotes, then whatever's in the middle of the string you interpret. In this case, there's a comma. Normally a comma would be a field separator, but in this case, it's a literal character. The literal case number 2 is if you're in a literal string and then you find a double quote, then that represents a single quote. If, on the other hand, you encountered a single quote, that means it must be the end of the literal case. And finally, here is a more extreme case. This is a file or a element that begins with double quotes and contains one of the reserved characters in the middle. So in this case, we have 3 quotes in a row, which means literal string, a double quote, and then the balance of the string ending with a double quote and a delimiting character. So I made up this test data. It said this is a file with quotes and a comma, phone number, and a time. And this illustrates the cases above. Here's the methods that I picked to try to solve this. At the beginning, I thought the cases were fairly simple and that I could just do an indented if, else, then, begin, again, parse my way through each element. And the cases were fairly straightforward. And then I started to write out the if, else, then, and it got kind of nasty. So then I said, all right, this is eligible then to be a state machine. So then I thought, well, okay, a table-driven state machine would be the most general. In this case, each table entry has the identifier or number for the state. It has then some decision elements and then linkage to following states. Well, it got a little bit complicated, and I was having trouble with whether I was going to build the table in binary or I was going to build it in hexadecimal, and it got messy. So then I said, all right, let's fall back on fourth. And so I'm going to use a logic-driven state machine as we see. The nodes of each state, one is the first character of the string, which is most important. Then any subsequent characters that are in a non-literal field, the subsequent characters that are in a literal field, and then there's an exception case of finding a quote in a literal field, which means a double quote. So here's the state machine. Please admire this gorgeous drawing. This is really shows the power of what you can do with PowerPoint. Just amazing. So on the left, we see a driving program, and it calls up, it works its way through the file, brings the file up, sets up some parsing, and then it extracts, it passes control to the first element of the state machine. So the box called first character is the initial state, and it samples the first character and makes a decision. If it encounters a double quote, it takes the path upward. If it has no double quote, it takes the path downward. The downward path is for a non-literal field. It means there would be no reserved characters in between. And so in that case, it's looking only for a comma, which is end of field. So the non-literal field state parses character by character recursively, working through to the end until it finds a comma. When it finds a comma over on the right-hand side, we see that it will return. Now, at this point, the scanning has been recursive, so upon a return, it threads backward through each state, or this particular state, repetitively works its way back to the first character, works its way back to the driver. If a double quote was encountered, then it takes the upper path, and it says this is a literal field. Now, as long as it does not encounter a quote, it makes the same recursive path, character by character by character. But in this case, if it encounters a quote literal, then it has to make a decision. Is this a quote in line or is it an ending quote? And so it gets a little tricky there. So it makes the assessment there, and it loops back to complete the literal field, or possibly it returns. If it hits a double quote, or if it hits an ending quote and a comma, then it returns. So let's look at the actual components in fourth. First is the driver program. The first line says the in character is initialized to 0. The out character is initialized to 0. This sets up our parsing. And now we begin the recursive change. This little word called vertical var is delimiting just for diagnostic and display. It helps us, as we'll see later, looking at the output. In green, the first character enters the state machine, and it now parses completely through until it reaches the concluding comma. The conclusion could either be a return or a comma. And at this point, it hits the while. Now, if it is a comma, it realizes there is more to follow. So it does the blue print field. This displays the full sequence of the item that it analyzed, puts a space at the end, and then it resets the out character buffer and repeats. So in this case, now it goes back to begin, and again, it does the recursive sequence, go through all those states until it comes back. If, however, it comes back with a return character, then it realizes this is the end of the line, and so it escapes the begin while repeat loop. It prints the field. We see the result for that output field, and then it returns back to begin for the remaining lines. So this is our control program. The first character, now we're getting a very comfortable fourth. We're seeing this is again the state machine node for first character. The fetch in character plus in character reads the character and increments the pointer for the next fetch. Then the case statement analyzes. If we see an ASCII quote, it says this must be a literal field, so it enters that node, transfers control to that node. If it encounters a comma, it says this is the end of a field, so it exits true. If it reaches an end of a return character, a hex OD, it returns false. Remember back to that outer driving program. Otherwise, if none of this takes place, then it must be a non-literal field. So in this case, the store out character and plus out character records the current character, and then it passes control looking for more characters to the non-literal field. The 666 at the end is just a dummy parameter because the end case requires one stack value which it chews up. So we put the 666 there to make end case happy. When we encounter the non-literal field choice, now we're doing the same recursive process again until we reach a comma or carriage return. So the in character plus in character fetches and analyzes the next in our input stream, and we examine the case. If it's an ASCII comma, again, this is the end of an element, we return true. If it's a hex OD, return false, and otherwise it's got to be something to process. So in this case, the out character just stores the character and the output buffer increments. And again, now it recurses, so it's calling itself back to non-literal field. So it re-enters itself. And in this case, it leaves the 777 as that required end case. So in this case, we either exit or we continue recursively for additional characters. In processing the literal field, again, a similar case statement. In this case, the first thing it's looking for is the OD, which is end of line. In this case, it is not allowed. It's unexpected. So in this case, we get an abort with a message that a format error 2. If we get an ASCII double quote, then we realize we have a quote in the literal stream, and so we move to a state to analyze that. Otherwise, it's retuned. Here in this case, we take the current character and put it into the output buffer, and we recurse and we continue analyzing the literal field. And again, the 888 is the dummy to make end case happy. The final state is finding a quote in literal. In this case, we've already had one quote, and now we're looking for a second quote in line. So if it get an ASCII double quote, in this case, then we put the sequence ASCII double quote out character. That stores the ASCII character in as the output buffer because we've had two double quotes in a row. And then we call literal field to continue the recursive process. If we get an ASCII comma, of course, we do the same as always. We exit true. We get an end of line, we exit false. And the final case is if none of these apply, we've got an error, and so we give a format error 1. Again, the error is in our input formatting. So here's the resulting report. Showing in red and green the fields. The first field is this is. The second field is a file. The third field says with quotes. The fourth field is the and comma, then the phone number and the time. So let's look at the output. Now you see the purpose of those vertical bars. This delimits what the fields look like because there could be embedded spaces and we want to reveal those. So in this case, we nicely extract the text. This is a file with quotes and a comma, and then the phone number and time. For the future, next final stage on this is to scan each data element and classify by data type. And getting into this, I found out this becomes a little bit on the hairy side too, so it's left for another project. The classifications I'm going to use is looking for text, dates, times, numbers, and formats such as email addresses. So what are the alternatives? In researching this, I saw an interesting post derived from GitHub by Matt Hodges, and he said, let's consider non-printing characters as separators. The ones he's proposing is to use the hexadecimal 31, I guess it's hex 31 as a field delimiter instead of the comma, and the hex 30 instead of the return for new lines. In this case, then, the beauty is that you need to do no analysis in between the field separators because those are all allowable printing characters. And of course, the trick then is to make our separators and reserved characters non-printing. Well, that technically is interesting, and possibly in a closed system it could be useful. But remember, the purpose of comma-separated files is that you can have them files totally editable, totally visible, totally printable, with no control characters of significance. So in this case, we now have the text in line with non-printing characters. And so if you tried to edit this or possibly include it, and if you're trying to do your copy with a Control A, Control V, and Control C, this is not going to work. So the old CSV seems to be holding its own. This would be fine for a file system or database that you have control over, but you've got to control both ends of it, the encoding and the decoding. Not good for editing. So conclusions, there are many subtle variations on CSV. The one that I'm using here is the output form from Excel, and it is very well behaved because it only puts the double quotes at the beginning and the end of a data element. Some of the other methods only embed the double quotes when and where needed, and so you have to be a little bit more diligent in the analysis. You can check Wikipedia for some of these alternatives. The list is very well done. And Excel seems to be quite robust in that it appears to accept many variations of the CSV format. It only generates the one that I reviewed here, but it does seem to accept quite a number of them. So that concludes my formal remarks. Let's see if I can return to control. Are there any comments or questions? Mercifully not. Thank you very much.
Let me comment, sort of need to. One of the major uses for Cozy is dealing with my accounts. So I posted to the discussion the link to the script that's got, I don't know, I've got a half a dozen CSV to and from CSV to essentially the database structure that Cozy list of lists structure that I use, which is very much designed on KX.com's structure, Arthur Whitney's structure. But one thing I mainly have run into the need to go and deal with embedded commas that are embedded in quotes, as opposed to the double quoting. I don't think I've ever handled that situation, which is used a lot in APL, but I just have not encountered that parsing of double quotes. But essentially, the vocabulary in Cozy for converting from I've never really played with JSON or XML, but essentially any of those sorts of translations are essentially trivial. You'll see that virtually all of my CSV related functions are short lines. In any case, yeah, it's there. I've got the link, but they're all in my furniture guy in an APL conference years ago talked about it takes a lot of living to make a house a home, which is an Edgar Guest thing. But once you have the system, then it takes a lot of furniture, a lot of individual functions like the CSV conversion and so forth to flesh it out, to supply the furniture to make it, an environment where you do these things as you need to. But
Thank
yeah,
you. It would be interesting to see this approach applied to XML and to Adobe Acrobat. Some years ago, I had to write a parsing program for Acrobat to do a translation to text, and it was, harder at the beginning and easier at the end, and worked out a minimal parsing for Acrobat. And this fourth case statement thing might be appropriate.
My number of files this weekend, but I was in a discussion where somebody had a complex method for parsing white space. I mean, the most fundamental delimiter, in a sense, in Forth, of course, is white space. And this was very complicated. I can't remember what the language was in that it was, but essentially, anything that's 32 or below, as a character is white space. And the two I run into in actually files from banks and so forth and credit card are either commas or horizontal tabs. So and then line feeds or new lines between the line separators.
So Bill,
Uh-huh.
let me ask you this. Let's say I'm somebody that doesn't know much, and that's almost literally true. And I'm seeing this video in a year. Will I have access to your code? Well, I want to do this, and it looks good, and looks interesting. Will I be able to look at your code? Is it going to be posted in the meeting notes?
Not worth the trouble. I had to be blunt about it. It's not worth the trouble for me to build this and post it, because this is not a complete closed application. It doesn't have extracting files, reading files. It doesn't have full formatting. This is an exposition on state machine, and so you learn the structure of using Forth as a state machine, but it is not an exhaustive exposition on handling CSV files.
So you're unwilling to put
I'm
the
not even
code
there
up
yet
with
myself.
a disclaimer at the top that says, okay, this isn't there yet. It's not a finished application. It's just some example code to illustrate my thinking associated with this YouTube talk. But I understand if you don't want to do that, that's fine too. Any other questions, comments?
It is an interesting observation that that fellow that you were referencing about the ASCII separator characters. It is sort of now, you've got me now wondering how come those didn't become more common, as a separator in general. It is sort of as you say, probably because they're not visible and so on. But it's an interesting, that was a sort of an interesting side note.
Well, back in the 70s, early 80s, in the handling of email, they realized that they either had to or wanted to. The designers said, we want to be transmitting ASCII only. So in the body of emails or associated with emails, it's ASCII only. So there they went to this modulo 36 alphabet or something like that, where each character is translated into a character and a half. And that's what goes on inside email. I don't think you see it these days, but for transmission inside email, there's a separate alphabet that's used or numerical translation that that forces all the body of emails to be printable characters. And I think this is just a holdover from that or a reflection of that. that at that time they were just saying control characters are poison in human communication.
I imagine it didn't help all of the inconsistency of like even carriage return line feed weren't consistent. So I suppose that would these other control characters are a mess. But yeah, interesting.
So speaking, if I may leave the topic, are we ready for a non sequitur, Bill? Do you have anything else in summary?
No, we're set. All done.
conclusion?
Thank you so much.
All right. Thank you.
Thanks for the use of the hall. All I ask for is a 20-minute head start.
We're always grateful to Bill, if for nothing else, for the accuracy and style and ability with which he delivers presentations on anything. Bill, you get the ball over the plate. That's
I will I'll point out an advertisement for the management. Excuse me. I'll have to talk later. I just drank tomato juice with hot. I just drank tomato juice with hot sauce. I can't talk.
All right, get back to us. I wanted in the for starting announcements to mention Jurgen's books on Amazon. We always, Dave Jaffe and I always, when we're in a bookstore talking about a bookstore, talk about all the fourth books are very popular because they're always sold out. But Amazon has fourth books, a lot of them from Jurgen. So whatever country you're in, go to that Amazon. And I put the name, which I'm loath to pronounce, Petoskey. Anyway, anybody that knows Georgian probably knows how to pronounce his name. Go to Amazon, enter that name, maybe use the expletive fourth, and he's got a bunch of stuff there, well worth the purchase. And there are other things on there on Amazon, but I did want to plug that at this time. So, are we ready, Brad, for the screenshot?
We are ready.
Okay, if you are on the lam or don't want to appear on the website, preserved in a still picture for posterity, now's the time to either change your name to something different from your actual name, or you can just log out and come back to us in a minute or two when Brad is done taking the picture. All right, I think everybody's ready.
No, wait for my video to come on. It sometimes takes a few seconds, so.
Yeah, we're getting a higher percentage than usual. If we can just get a few more folks to come on camera. I'm dying to know who Zoom user is, but
Yeah, me too. I asked him to change his name to his name at the beginning, but did not achieve compliance. I wish there was a technique. I was in a meeting once where somebody changed my name. I had set my name to something smart alecky, and they didn't think well of that. I think they were wearing a necktie at the time, so it cut off the flow of blood to their brain. But I don't think Zoom has that capability. So is Dave actually videoed now? Let me scroll through. I see Dave's
Dave is up. So
all right, everybody, look how they want to look.
Okay, on the count of roughly three, as it actually is for whatever reason non-trivially slow for me to hit the button. 1, 2, 3. All right, got it.
let's call that a win then. Thank you, gentlemen, for your patience with
It's actually
my...
better looking than most of the ones we do.
I'll call that a win. Thank you, Brad, and thank you, everyone. So speaking of Brad, Brad's going to introduce himself and tell us about his talk, and then deliver his talk, and then end his talk.
Alrighty, give me 1 second.
And if you're not talking, be sure to mute.
All right, is that visible? Oops, not visible. There we go.